When we talk about blockchain's big dilemma, it usually comes down to one thing: the impossible triangle: speed, security, and decentralization. Most blockchains can nail two of those, but they always end up sacrificing the third. But Avalanche says it doesn't have to be this way. It takes a radically different approach to blockchain design. It all began back in the academic labs of Cornell University. Emin Gun-Sirer, a well-respected computer scientist in the blockchain space who set out to fix shortcomings of earlier blockchain. His research led to a new kind of consensus mechanism, one that didn't rely on energy-hungry mining or centralized voting power. The idea was published in a white paper in 2018, and it quickly gained traction. With the support of serious venture capital, including names like Andreessen Horowitz, Ava Labs was born. By 2020, Avalanche had launched its mainnet, selling out its $42 million token offering in just a few hours. Instead of running everything through a single congested network like Ethereum, Avalanche divides responsibilities between three purpose-built blockchains. The X chain handles asset creation and transfers. It's optimized for speed using a structure that allows transactions to process in parallel. The P chain is the coordinator. It keeps track of validators and manages subnets, the many blockchains that can be spun up by developers or organizations. And finally, the C chain is where the magic happens for smart contracts. It's fully Ethereum compatible, so developers can use familiar tools like MetaMask and Solidity, but on a much faster and cheaper network. This division allows Avalanche to scale without congesting the entire network, but what really sets it apart is its consensus model. Rather than relying on all validators to agree on every transaction, Avalanche uses probabilistic sampling. The result is concrete: transactions that finalize in under a second and throughput that can hit over 4,500 transactions per second. Even more interesting, adding more validators actually speeds up the network rather than slowing it down, which is the opposite of how most blockchains behave. Let's talk about subnets, the feature that really sets Avalanche apart. Subnets are custom blockchain networks that developers or enterprises can create within the Avalanche ecosystem. They can have their own rules, tokens, governance, and even compliance frameworks, but they still inherit the security of Avalanche's main network. Each subnet is a fully sovereign blockchain, but it benefits from Avalanche's infrastructure and security. To make these subnets interoperable, Avalanche uses warp messaging, which acts like a universal translator between subnets. It avoids the usual bridge vulnerabilities that have cost the industry billions in hacks. Avalanche's ecosystem includes DeFi protocols like Benqi, a lending and liquid staking platform, and Trader Joe, a popular decentralized exchange. There's YieldYak, an auto-compounding yield optimizer that works seamlessly across protocols. In gaming, Avalanche is pushing boundaries. DeFi Kingdoms pioneered on-chain game economies with millions of transactions, while MapleStory Universe recently hit over 1 million daily transactions on Avalanche in June of 2025. On the enterprise side, real-world asset tokenization is gaining serious traction. Platforms like Benqi brought hundreds of billions in real estate on-chain. Grove Finance launched with a goal of $250 million in tokenized assets. Even Visa recently announced support for stablecoin payments on Avalanche, bringing mainstream use cases closer than ever. Avalanche's token, AVAX, is used for transaction fees, staking, and governance. It has a capped supply of 720 million, and a portion of every transaction fee is burned, reducing supply over time. Validators need to stake 2,000 AVAX to participate, which creates strong incentives for reliability and performance. Smaller holders can delegate as little as 25 AVAX to existing validators and still earn rewards. High staking requirement makes it harder for everyday users to become validators. There's also some centralization in decision-making, with Ava Labs and the Avalanche Foundation still playing large roles in governance. Subnet fragmentation can create liquidity silos where different apps can't easily interact because they're on separate networks, and competition from Ethereum Layer 2s and chains like Solana is real. Ethereum's momentum, tooling, and community still dominate mindshare. Still, Avalanche is carving out a distinct lane. It's fast, flexible, and increasingly enterprise-ready. It's not trying to be the next Ethereum. It's building something different, an ecosystem of purpose-built chains that operate together without sacrificing security or decentralization. In a space where so many projects promise the moon and deliver mediocrity, Avalanche stands out as one of the few platforms turning deep research into real, scalable infrastructure.